Dante Certification Program Level 3. This module will go over some advanced clocking concepts. As you probably understand by now, clocking is crucial when it comes to Dante networking. In previous Dante courses, you were introduced to the concept of PTP, Precision Time Protocol. As you probably recall, Dante uses PTP to synchronize clocks. This module will go over several things such as how does a network synchronize media clocks, what does an external clock do, network synchronization, synchronizing time, and time in PTP. In Level 1, we covered the need for a word clock in the basic digital audio section. Word clock defines the start of the word, which is the group of binary digits that make up the numeric representation of a sample. A word clock does not define the bit depth at merely the start of the string of bits. A word clock is at the sample rate. So, how does our legacy digital device make sense of this? It's a common belief that giving an external word clock to a device replaces its internal clock. The truth is, it doesn't. Consider a 24-bit 48 kHz AES audio pair. The word clock will pulse 48,000 times per second. But the data is 24 times 2 times 48,000, which means it's 2.3 megabits per second for 2 channels of audio. So, in order to run a counter to capture those bits, the device receiving the data must have a higher frequency clock inside it. An external word clock definitely does something. We know this from basic experimentation. If we don't have one master and slaves clocking from it, we get crackles or no audio. The external clock is more correctly a sync reference. The external clock allows the slave device to align its internal clock oscillators with those of the master device. Typically, a master clock device drives pulses down a cable. This device can be an audio device or a dedicated master clock. The master clock device must always be connected to all of its slaves. If the master clock device is removed or it fails, then the slaves will cease to be synchronized. Consider the propagation time through the cable. Compensating for this is not part of the standard word clocking. Dante guarantees microsecond sync at any point in the network. How does this work? The concept of digital clocking is there to keep devices in time. On legacy systems, a clock is distributed. In modern network systems, time can be distributed. Distributing time has many distinct advantages. Time is expressed in hours, minutes, seconds, or divisions of a second. Clock is just a number of pulses in a second. There's no concept of a wall clock time. The idea of distributing time over a network started with British Railways. As rail networks grew, it became necessary to have a timetable. It was not acceptable for a train to just show up and leave at arbitrary times. Think of how annoying that was. How did this problem get solved? Remember, there were no telephones at that time. Simple. They put a reference clock physically onto the train. At each station, there was a station clock. The station master set the station clock as precisely as he could to the clock that was picked up off the train. The train then carried on, and the next station repeated the process. Every so often, this process was repeated to keep the stations in time. This was the birth of standard time. It's also pretty much how PTP works. Of course, synchronizing in seconds is nowhere near good enough for audio. Luckily, IEEE 1588, also known as Precision Time Protocol or PTP, is a lot better. IEEE 1588 has a resolution of nanoseconds. The PTP master device has the reference time. It transmits this reference time onto the network. So, how exactly does this work in Dante? The master clock sends a sync message. This is essentially, hello, this is sync message 1435. It's this time here. In this case, Monday the 8th, 2017. This allows the slave devices to set their individual timepieces, but we are trying to keep these timepieces aligned. Every time a piece runs at a slightly different speed to each other, wouldn't it be good if we could convey this? PTP has thought of this. The master clock sends a sync follow-up message. This message says, I actually sent that message on Monday the 8th, 2017, and it gives the time. The receiving clock can then compare the time it received the sync message against the actual time from the follow-up message to determine if it's running faster or slower than the master. We saw how frames can even slightly potentially get in the way of each other. This is also true for PTP frames. In reality, the slave device needs to get an average of the messages it receives from the master to not jump to conclusions. PTP also considers how to be robust in a network. So, without real information, the slave is still sort of guessing what the time is at the master. Wouldn't it be good if an idea of the network delay was known? This is why, once the slave gets its speed close, it starts to send delay request messages back to the master. Now, the master says, "Hello, this is a delay request message sent on Monday the 8th, 2017, May, at," and it gives the precise time. And then it says, "What time did you get it?" Then the device replies, "I am replying to this message on Monday the 8th, 2017, May, and it gives the precise time." The slave then has a good idea of what the delay caused by the network was, and it can use this information along with the sync packets to predict how much it should pull its local timepiece to stay aligned. The master continues to send sync and follow-up messages. The slave continues to send delay request messages. Dante has a sync interval of 0.25 seconds, that is 4 packets per second. The slaves obtain tight synchronization very quickly. Now, if we remove the master clock sometime later, the slaves have a very good idea of what the relative speed of the master clock was. The slaves also have a very accurate idea of what the time is at the master device and will have set their timepieces accordingly. This means any slave can now easily become the master. The subsequent slaves are synchronous enough with the new master that their audio clock is unaffected. The synchronization of the system is not dependent on a single permanent fixed master. Time is time. I can chop it into however many parts I like. Audio and video clocks are simply the inverse of time. This is what goes on behind the scenes when Dante takes care of all the clocking. The reason why clock master changes do not have an audible impact in Dante is precisely because of this.